Podcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to part 2 of Christie Terra overview. My name is Nick Wheeler, and well, I introduced myself yesterday for those who were with us yesterday morning. I look after market development for the video processing products for Christie across Europe, Middle East, and Africa. And I'm joined today by Tom Barker, who's going to be my wingman, and he looks after market development as well for Terra and Pandora's Box across Europe.
Good morning, everybody.
So, thank you for joining us. We've had literally hundreds of people register for this course, both yesterday and today, from across the world. It's been an amazing response, so many thanks indeed. Please feel free to use the question box, the question like chat-like tool to send us your questions during the presentation. And what we'll do is that we'll stay online after the end of the presentation and try and answer some of them. Those that we can't answer immediately.
I will answer some of the questions during the presentation.
Okay, well, thanks, Tom. Take some pressure off at the end there. And anyway, we'll answer some of the questions at the end of the presentation, but we will answer all of them over time. So don't hesitate to do that for us. So yesterday in part 1, I sort of talked a bit about the SDVoE Alliance, and I went through what Christie Terra is, the products and the applications, a bit of the manager, and I talked about the Zurich Opera case study. Today we're going to go a little bit more into detail on Terra. We're going to talk about the operating modes for the receivers, the RX, and the transmitters, the TX. And I'm also going to talk a little bit about audio management. Then we'll talk a little bit about networking with Terra. Now, this isn't a networking course, so I'm not going to teach anyone how to program or configure a switch. The goal of this particular webinar is to teach you or to demystify the networking aspect of video over IP and the SDVoE. Okay, so just to simplify this, please let us know if you want us to go into a little bit more detail into things like VLANs and lags and stacks and so on, using the question tool. And yeah, if we get a lot of response, then yeah, we can certainly put something together. We'll do maybe a specific webinar on networking. I'll go through a little bit about cables and SAP Plus transceivers and so on, the different types, and what you can do and can't do and so on. And I'll finish by with a case study of a satellite control center in France, which belongs to Orange. Which is an interesting application for Terra. So Terra operating modes. So first of all, I'm going to talk about the receivers. So an RX is a receiver. So anytime you hear me mention an RX, I'm talking about a Terra receiver. The first one I'm going to talk about today is Genlock mode. Now what that does is actually locks the display to the source. So whatever the source transmits via the transmitter will come out at the other end on the receiver. So if it's 4K in on the TX, you'll get 4K out on the RX. It's basically an extension of what that source is. There is HDCP and EDID in this as well. And also from an audio perspective, the audio format is always respected. So whatever audio format you have, whether it's like stereo or DTS or Dolby or whatever, that the source is inputting into the transmitter, that will come out at the other end on the receiver. This particular mode has the lowest latency, 100 microseconds. 100 microseconds is 0.1 milliseconds. So for all intents and purposes for the user, it's pretty much immediate. It's instantaneous. There are two ways of using the Genlock mode. You can either use it in sort of extension transmitted directly to a receiver, or we can also use it using an Ethernet switch as matrix, as I was discussing yesterday. So I told you yesterday. So you can use this mode to in the matrix switch mode, although when you do switch a source on a receiver in Genlock mode, it's actually going to drop the source. It's going to unsubscribe to the source before subscribing to a new one. So it is going to go through a black. But what you actually do put into the transmitter actually will always come out at the other end on the receiver. So this is like an extension mode, but you can use the switch as the matrix switcher in that extension mode. I hope that's clear for everyone. The next mode I'm going to talk about is the Genlock scaling mode. So here, the display is Genlock to the source, and the video output on the RX, it can be scaled to match the display that it's connected to. So if you need the receiver to always output 4K, then you can do this. It adds a little bit of delay. That's about 3 milliseconds, which is still very, very low, very low latency. And this can still be used for switching as well. But the output from the receiver will not change resolution, contrary to the Genlock mode, where the output from the receiver to the display will change resolution depending on the input to the transmitter that it's getting the signal from. Okay. The fast switch mode, this is the sort of the usual mode that's used for sort of video switching, for matrix switching using SDVoE. It's sort of the default operating mode for this. Again, the receiver, you give it a fixed output resolution depending on what your display is, whether it's HD or 4K or whatever. And what the receiver does, it sort of buffers a little bit the video, so it adds a little bit more delay on this, but the switching is much more smoother. There's only 16 milliseconds of delay. I'm not counting the 100 microseconds, which is instantaneous. There's only 16 milliseconds of delay in this mode, so you can still use this with KVM and so on and so forth, because the latency is still too low. Now the audio can be managed in this mode, so you can, and I'm going to talk about this a little bit later on, so you can change a little, you can sort of manage and change the audio, what you want to do with it in this mode. And the EDID and HDCP is maintained, and that what sort of permits the smooth and the quicker switching in this mode. So we've got 3 different video modes which you can use in the sort of matrix switching mode. Now, Videowall mode, slightly different. I sort of touched on this very briefly yesterday. And here again, on the receiver end, the receiver is given the resolution of the tile or the LED controller or whatever the display device that you're using. So it's a fixed output resolution, okay, on the receiver end. But the receivers are locked together, okay, using the specific sync that SDVoE has. Okay, so the receivers are locked together, and that sort of permits you to take a single source and spread it across multiple tiles or multiple receivers, and they will always be in sync. Okay. It does have EDID and HTTP handshakes. For when you're switching sources, there is a little bit of delay on this as well. The same as for the fast switch mode, so we can actually scale the source across the different receivers and so on. It's still only 16 milliseconds. And the output resolutions on the receivers can be either standard resolutions, or they can be user defined. So there is in fact a VISA calculator that can be used within the manager software, so you can actually match the receiver output to the resolution, for example, that you may need on your LED controller, for example. So it doesn't have to be standard resolutions. It can be user-defined resolutions and frame rates. Now, one very interesting thing that you can do in Videowall mode is actually change the mode of the receivers at any time. So you can go from you can change the mode on the receivers from a Videowall mode, where you have a single image spread across, in this example, a 2x2 array. You can switch them all to fast switch mode and have a different source displayed in each quadrant, so a different source displayed by each receiver. And then you can switch again, either one or more of them, or all of the receivers, to multi-view mode and fast switch. So you can have different modes on being used with different receivers within the same video wall. And all that is actually saved in the Terra layouts. So you can recall a layout that shows a single source spread across the whole wall. Then you can recall a different layout in which you see a different source in each quadrant of the video wall, or each display of the video wall. So in that case, the receivers switch from video wall mode to fast switch mode. And then you can recall yet again another layout and switch one or more of the quadrants into multi-view or something else. And you can go backwards and forwards between these layouts at any one time. So really the nice thing about this system is that the receiver, once it's configured, doesn't have to stay with it in the same mode all the time. So it makes it very flexible, especially in the control rooms where you want to be able to create different layouts depending on the situation and so on, and sort of move things around your video wall. That's something that's really very useful. I'll be talking a little bit about that later on during the case study with the satellite control room. This is another, so I've just talked about multi-view mode, but that's the last mode that the RX can have. So the receiver in multi-view mode still has a fixed output resolution, so it's either standard or user defined. And the receiver can display up to 32 sources. Okay, so you're going to have 32 thumbnails, as it were, displayed by the receiver. It still does add a little bit of delay, 16 milliseconds, sorry, as it buffers all these different sources to be able to display them on the screen or on the display. But the sources that it uses, and I'm going to go into a little bit more detail about this now. The source that it uses isn't doesn't come from the resolution of the transmitter, the native resolution of the source that goes into the transmitter. Okay, it's something that we call stream 1, and I'm going to go into this now. So on the transmitter side in multi-view mode, what happens is the transmitter will always publish onto the SDVoE network the video inputs in its native resolution. Okay, this is the blue part that you're seeing at the bottom. Okay, so stream 0 will always be the native resolution of the display port or the HDMI input. So if you input HD into DisplayPort or HDMI, then stream 0 is going to be HD, 1920 by 1080 at 60 or whatever frame rate it is. Okay, if you input 4K, then stream 0 is going to be 4K at 30 or 60 or whatever frame rate you want to use. Now, stream 1, so this is the yellow part at the top, just above the TX, you can see on the slide here. Stream 1 is a scaled down version of that. And that could also be published onto the SDVoE network. And it's this stream 1 that gets subscribed to by the receiver when it's in multi-view mode. Okay, and the receiver can subscribe to several stream 1 publications at the same time. So what happens is you need to be able to manage the bandwidth that the TX is using between stream 0 and stream 1 and the rest of the control, the USB and the network stuff. Okay, and this is something that's pretty fundamental when you're using the multi-view mode, and this is actually part of the SDVoE sort of standard. This is what happens. So part of the bandwidth on the SDVoE network is going to be used up by stream 0, the native resolution, and the rest of the bandwidth will be used for everything else. So stream 1, the audio, RS-232, infrared, USB, and network. Okay, the Ethernet, sort of the gigabyte Ethernet that sort of piggybacks on the back of the SDVoE network. So if the native resolution of the source going into the TX is like 720p at 60 or 1080p at 30, for example, it's only using up 1.5 gigabytes of bandwidth. Now this is uncompressed, okay? There's no compression here. So uncompressed 720p at 60 will take up about 1.5 gigabytes of bandwidth on the SDVoE network. The rest of that bandwidth, 8.5 gigabytes, is available for everything else. Now, Terra and the TX and the SDVoE standard will prioritize stream 1, okay, on the network. Okay, so as the resolution, the native resolution increases with your input, so now we're 1080p at 60, okay, on the DisplayPort or HDMI input, that will take up 3.4 gigabytes of bandwidth, and the transmitter will prioritize that, so it will allocate less bandwidth for the rest of what we need, so stream 1 and everything else. And as that increases, so now we're up to UHD at 30 frames, or 2560 by 1630. We're up to 6.5 gigs of bandwidth. You can see that the bandwidth that's left for everything else decreases. Okay, so when you get up to 2160p, so when you get up to 4K at 60, it's taking up 8.5 or even sometimes 9 gigabytes of bandwidth, and so you only have 1.5 gigabytes of bandwidth left for everything else, for the stream 1, the downscale version of the video signal, the audio, and everything else. So what this means is that on the TX side, the maximum bandwidth that the TX can actually publish onto the network is 10 gigabytes. So stream 1 has to be able to fit into what's left of the bandwidth once stream 0, the native resolution, is published on the network. And so to be able to do that, what Terra does, it actually cuts the frame rate to 50% of what it is. So if your input is UHD at 60 frames a second, then it's going to cut the frame rate in half to 30 frames a second to be able to conserve bandwidth. And there are a couple of rules of thumb that you need to be able to understand to be able to use the multi-viewer without running into too many issues, because obviously you can't go over 10 gigabytes, on the TX, being published on the TX. So, 4K 60 is taking up 8.5 gigabytes. If you want the thumbnail or the stream 0 to be 1920 by 1080, even at 30 frames a second, that's going to take up at least 1.5 gigabytes. So there's a very good chance that that actually won't fit into the 10 gigabyte bandwidth that the TX is publishing on the network. Okay, so once you get into, so the higher the native resolution is on stream 0, the lower resolution you have to use on stream 1, so that it fits into the 10 gigabyte bandwidth. So stream 0 and stream 1 must always fit into the 10G bandwidth. That's sort of the physical size of the pipe that's on the output, as it were, from the TX onto the network. Now, on the receiver end, now the receivers can display up to 32 sources at the same time, but the sum total of the resolution of all those little windows that you're displaying in terms of pixels, it actually must fit into 4K. Okay, so there are some instances where you might be oversubscribing the RX, where you're trying to get the RX to subscribe to more than it can chew, more than it can actually import over the 10 gigabyte bandwidth. Okay, so in these examples on the screen here, on the top left, you've got a UHD screen, so 3840 by 2160, and we're using 1080p sources at 30, which takes up 6 gigabytes. So that should work for it. That should actually work. But so long as the sources, remember, so long as the sources can handle it. So the TX itself on the transmitter, if the transmitter was 4K, it would probably find it very hard to transmit stream 1 at 1080p at 30 frames a second, because it's actually 1.5 gigabytes. So you may be right on the limit there. However, if the multi-view screen is HD, so the output of the receiver is HD, then obviously, in a quadrant, so in a quad split, then those windows are going to be physically a lot smaller. Okay, so they're going to be 720p at 30 frames a second. Now, a 720p 30 frames a second takes up about 3/4 of a gigabyte, so 0.75 gigabytes. And this is a resolution that could be handled by stream 1 on a transmitter that is transmitting 4K at the same time. Okay, so 4K 60 is taking up about 8.5 or 8.5 to 9 megabytes of bandwidth, and stream 1, if it's in 720p, is only taking up 0.75 gigabytes, so it fits into the pipe. Okay, so that would work. Okay, so you have to be a little bit careful of what you do on the transmitter side and receiver side, so that you always remain within the 10 gigabyte bandwidth. And the Terra Manager will warn you if you try to use too much, you've tried to pull too much bandwidth onto the receiver, so if you try to oversubscribe it. And likewise, it will warn you if the stream 1 of a transmitter that's being used somewhere on the network is being requested in a different size as well. So if I go back to back here to this slide, then as you can see, the video is being published on the network twice, but only twice in two different sizes. So stream 0 in its native resolution and stream 1 in a downscale version. Now that downscale version, stream 1, is published on the network, and that can be subscribed to by different multi-viewers on different receivers at the same time, so long as the downscaling stays the same on all the receivers. So the size that you're using, the physical size in pixels on all the receivers is identical for that particular source. I hope that's clear. Please let us know if you've got any questions regarding that. So I'll go into a little bit more detail at the end. I hope I've been clear about this anyway, but the multi-viewer is a really useful tool. And because the receiver can change modes, you can switch backwards and forwards, you can have different multi-viewer layouts with different sizes and so on. So it's a very flexible tool. I've been talking a lot about bandwidth. This is just a sort of brief overview of video bandwidth to different resolutions. This is what you're looking at is the real video bandwidth. Okay, for example, at UHD 3840 by 2160 at 60 frames a second, the HDMI standard is, what HDMI is going to say is that, well, it actually takes up 18 gigabytes worth of bandwidth. Well, the video itself, the only part that interests us, really, SDVoE, only takes up 12 gigabytes. And that's all we use. The rest we discard, okay? So it's only the 12 gigabytes of actual video bandwidth that we use, and it's only that actually gets compressed. And this is permits us to do very light compression, so we can fit that resolution into a 10 gigabyte or a 9 gigabyte pipe. So the pipeline, pixel pipeline compression permits us to do that. But again, we strip the signal, whether it's HDMI DisplayPort, we strip the signal of everything that we don't need, and we only grab the actual pixels. A little bit about audio management now, because that's quite an interesting thing. Like I said yesterday, the switch that you're using to be able to connect all these TXs and RXs on the network is actually being used as a matrix switcher, and that's what you really need to look at it as being. It's not just a video matrix switcher, it's an audio matrix switcher, it's a USB matrix switcher as well, okay, and it's RS-232 and infrared and so on, and you can switch all these different types of signals separately over the network, but you're still using just a single network switch. And the interesting thing is that from an audio perspective, we can do several different things. So the audio signal, like every other signal that's connected to, or type of signal that's connected to the TX, can be routed separately, even if it's embedded. Okay, so even if you've got embedded HDMI audio or even on DisplayPort, you can actually send that separately from the video, and it can be downmixed to analog stereo on an RX or not. It's up to you to decide what you want to do. So an RX can actually receive separate video and analog audio feeds from different sources, and the RX can embed the analog stereo audio onto an HDMI output or route the audio to the analog stereo output. Okay. So you've got a lot of flexibility there of what you can do with audio. So whether the audio is embedded or not, whether you're using the analog stereo inputs on the TX or whether it's embedded, you can switch them completely separately over the network. So you can manage your audio sources completely separately from the video. Now on the transmitter, the audio connector can be an input or an output. So an analog stereo input is, when it's used as an input, is routed just like the HDMI video signal over the network. So the analog audio and the embedded audio can be transmitted at the same time. So you can have an analog audio source and a different audio source embedded on the HDMI input, and they can be transmitted at the same time, obviously routed to different destinations. But the connector on the transmitter can also be an output as well. You can also configure it as an output, so you can have like a loop through on the TX of the audio that's coming in on the HDMI input, for example. So you can have your TX and your sources and your audio systems in the same rack, okay, and have a loop through, sort of loop out from the TX into your audio system, and have the receivers or the RX, very close to where your displays are. And you don't necessarily have to use an audio output on a receiver to be able to feed back into your audio system. Okay, so you've got a lot of flexibility in terms of audio management on how to manage audio, which is sometimes an issue. And you're still using that same switch, that same network switch, to do all the switching across the the different endpoints. So just to summarize, what happens with the different audio formats in Genlock modes, I mentioned briefly earlier on, whether it's directly a direct connection between TX and RX, or whether it's connected, they're connected over using a switch. In Genlock mode, especially the audio formats are delivered as in. So if you've got Dolby or NTMS or anything else that's actually being input into the TX, that will actually come out on the RX. Okay. In all the other video modes, Genlock scaling, fast switch, multi-viewer, and video wall, the audio formats that are supported are only stereo or LPCM formats. Okay, so you wouldn't be able to transmit Dolby and MTS and so on when you're using Genlock's scaling or fast switch or whatever. I hope that's clear for everyone. So a little bit about networking now with Terra. So the first thing is that we need to go through the requirements for the network switch. The most important thing is obviously it needs a 10 gigabyte network switch. It needs to be non-blocking, so it needs to be able to support 10 gigabytes on all the ports at the same time, simultaneously. It needs to be a level 2 or a level 3 managed switch. So because the network needs to be multicast, it needs the most important things that needs to have is IGMP version 2 and IGMP snooping, the querier and the fast sleeve. Now Terra uses multicast in order to be able to sort of manage the bandwidth efficiently. So in much the same way as web conferencing and you know, IPTV. Although the controller is actually that's unicast between the control PC and the controller, that's unicast, but between the SDVoE endpoints, the TX and the RX, all of that is handled using multicast, which is really important, and that permits us to be able to do everything that we can do with with Terra, with SDVoE technology. So there's it means that there's no oversubscription of the RX because the RX is receiving everything at the same time. So what happens is what multicast permits us to do is that the RX, we tell the RX to subscribe to what a transmitter, a TX, is actually publishing. So it's just this subscription process which makes this whole thing so efficient. So in terms of multicast addressing, so the transmitter is going to publish a certain number of things. So obviously the two video streams, the audio, the analog audio, and so on and so forth, and the receiver is going to subscribe to these things as well. The multi-view, as I said before, can subscribe up to 32 addresses. I think I said 36 earlier on, so my apologies for that. It's in fact 32. The multicast addresses are assigned by the system, okay? So you don't need to go into that at all, okay? The controller is going to do that for you. So that's for a user perspective, and from an installation perspective, it's completely transparent. Okay, single switch installations are obviously the easiest ones. Again, the switch has to be multicast mode. I've gone through this with snooping, the querying, the fast sleeve, and the switch should be able to drop unknown multicast packets to be able to maintain the bandwidth efficiency. So normally speaking, a single switch would have a single VLAN by default. So this is pretty much plug and play really, especially when you're using some of the Netgear stuff, switches, the 4,300, 4,500 switches. But that doesn't mean to say that you can't create specific VLANs within that same single switch, or to be able to segregate different sources and different destinations. So you still can do that. It just takes a little bit of programming on the switch, but it's really not rocket science at all. Now, in a multi-switch environment, the switches have to be configured in exactly the same way, with the same the same configuration. So with snooping and query and so on. And the best way to link switches together is stacking. You can use VLANs and obviously and so on and so forth. And again, if there's enough requests for a specific webinar to go into that kind of thing, that we'll put something together for you. So please let us know on the questions in the question tool. But the most important thing is to manage the bandwidth really between those switches, and this is what I'm going to try and talk about over the next couple of slides. So in a multi-switch environment, what you've got to remember is that the TX, the transmitters are always going to try and publish a maximum, up to potentially a maximum of 10 G on the network, and the Terra RX are always going to try and subscribe to a maximum of 10 G. So in the example on the left, this is a two-switch environment, and what we've done is we've put all the TX on one switch and all the RX on the other, and so obviously 6 transmitters on the top switch are actually going to try to publish, 60 gigabytes worth of data onto the network. The Terra, the RX down below, they're going to try and start pulling potentially all of those streams on their inputs, as it were. So you're going to need 60 gigabytes a 60 gigabyte link between those two switches, so that you have enough bandwidth for potentially each separate receiver subscribing to each separate transmitter. Okay, so each transmitter would be sending out 10G, and each receiver would potentially be subscribing to its, to a different transmitter, and so potentially sort of receiving 10 gigabytes. So you need 60 gigabytes, a 60 gigabyte link in this example, which is not a very efficient use of this kind of configuration. Now, on the right-hand side, if you balanced the TX and the RX between the two switches, because the links between the switches, so the SFP plus links, actually transmit 10 gigabytes both ways. So the SFP plus connectors and the fibers are LC-LC, okay? So you've got full duplex sort of cabling fiber cables between the switches. You've actually got, for each cable, you've got 10 gigabytes going one way and 10 gigabytes going the other way, okay, for each connector and each cable. So when you balance the Terra TX and the RX up between the two switches, as I've done on the right-hand side, well, the bandwidth that's required between the switches falls from 60 gigabytes to 30 gigabytes, because you're only ever going to use up a maximum of 30 gigabytes going from top to bottom, because there are only 3 TX and 3 RX on the top and 3 TX and RX on the bottom. And you've only going to have 30 gigabytes going back the other way. So you only need, in this example, 3 10 gigabyte links between the switches. You could also do this, if you've got a single 40 gigabyte link between the switch, then obviously that would work, of course. But this just shows you how balancing the TX and the RX in terms of bandwidth across the switches changes radically the the bandwidth requirements in the uplink. I've got another couple of examples here where we're doing something a little bit different. So on the example on the left-hand side, in this Terra configuration, there are only 2 transmitters, and all the other devices are receivers, both on the top. So you've got 4 receivers on the top switch and 6 on the bottom. Now, because there are only 2 transmitters that are only ever going to be able to publish 10 gigabytes each, you only need a 20 gigabyte link going down between the switches, because on the RX side, because we're using multicast, the Terra RX will only ever be able to pull 20 gigabytes from the top switch. Okay, so that's pretty simple. On the example on the right-hand side, it's a little bit different now. So we've got 2 TX and 4 RX still on the top switch, and the bottom switch we've got 3 transmitters and 3 receivers. Now here, the maximum that the RX on the bottom switch are going to be pulling from the top switch is going to be 20 gigabytes, because there are only 2 transmitters. And the maximum that the 4 RX on the top switch that are going to be pulling from the bottom switch is 30 gigabytes, because there are 3 transmitters there. So in this instance, all you need is 30 gigabytes, an uplink of 30 gigabytes between the switches. And because those connections, so those links are bi-directional, because you have 30 gigabytes, you obviously have enough, or more than enough bandwidth, to go from between the top switch and the bottom switch for the RX that may subscribe to the TX that are on the top switch. They're connected to the top switch. I hope that's clear for everyone. So it's this is sort of fundamental in when you're designing your network in terms of links and so on and bandwidth between them. If the more you can balance the TX and the RX up between the different switches, the less bandwidth you're going to use or the less bandwidth that you're going to require between the switches. So some hardware examples now, getting down to the switches, which I'm pretty sure is a question that everyone is probably thinking about. So I'm going to talk a little bit about Netgear, because Netgear switches, the 4300 and 4500 switches, because Netgear are part of the alliance, they're a founding member of the SDVoE alliance, and they've been like us. They are very active in the market and with the alliance and the SDVoE technology. And so what they've done is, and this sort of what they tried to do is to make it extremely simple for anyone to be able to deploy an SDVoE solution. Okay, so they've actually made their 4300 and 4500 series switches SDVoE compliant, compatible out of the box. So it's literally, they're literally plug and play. So if you buy, if you buy a Netgear M4300 or M4500 network switch, when you take it out of the box, you don't need to do anything to it. You don't need to go and configure multicast or the snooping or the query or the fast feed or anything. All that is already done. You can put it into the rack and you can connect everything up and you can connect all your devices up, the TX and the RX up to it, turn everything on, and it will work. You literally don't need to do anything. It's plug and play. It really is plug and play. That's how easy it is. You can have up to 96 ports in a single switch. So on both series. The difference between the two, the M4300 and M4500, are the stacking links. It's limited to 40 gigs on the 4300, and you can have 100 gig stacking links on the 4500. Now, one thing that to make the stacking easy, Netgear have come up with a great feature that they call IGMP+, and it sort of automates multicast across the network, across layer 2 networks in spine and leaf topology. So the switches are going to be talking to each other, and they will sort of auto configure each other in in multicast. So you actually don't have, literally you can connect them up and they will aggregate the links and so on by themselves. You literally don't have to do anything at all, unless you want to go in and create your own specific VLANs and so on, depending on the destination, sources and destinations and so on, if you want to segregate those. So all of this, plug and play, works out of the box, and that's exactly what we've done in a lot of our installations. So it really does make life a lot easier, and it sort of demystifies, it takes all the complication out of deploying video over IP. Of course, Netgear aren't the only switch manufacturer out there. There's Cisco, and there's Blackbox, and there's Arista, and so on and so forth. And SDVoE will work with any non-blocking level 2 programmable switch. Okay. The only difference is now is that you're going to have to go in and program the switch, and enable the features that are required for SDVoE, and also disable some of the QoS stuff on the switch that is not required, and that can actually slow things down and create issues for video over IP. So all of this has to be done manually, but it's perfectly possible. Things to look for when if you want to use other manufacturers, you just need to make sure that the stacking bandwidth and the switching capacity is sufficient for your for what you want to do. Okay. Going back to the Netgear switches, they are non-blocking, and you can load all the ports up with 10 gigs, and the switching bandwidth is more than sufficient. So it's really a no-brainer. With other manufacturers, in this instance, you'll have to go in and just make sure that the switching capability and the bandwidth is sufficient for what you want to do. Now, a little bit about cabling as well I want to touch on today. Very different options. I get a lot of questions about this. Can I use existing copper cables, and if so, how long can, what's the maximum length, and so on and so on and so forth. So that's why I'm going into this today. So there are different types of cable that are available. There's like twin-X or direct attached cables, which actually have the SFP plus transceiver directly attached to the cables, and you can have these exist in different lengths, and either in copper or fiber. And we use these a lot actually in our installations where the TX are in the same rack or very close to the sources and the switches and the switch. So you don't need to be able to. You don't need fiber for that. So in fact, our demo. We actually used the twin-X, for our demo kits as well. So depending on whether it's passive or active, you can get up to 5 or 7 meters or 20 meters using fiber. SFP plus come in sort of different types with RJ45 connector, a multimode OM3 or multimode OM4 or single mode. And depending on what you want to do, you can go, you can have more or less distance. So SFP plus on RJ45, you can get up to 100 meters in theory, but if you're actually running 4K 60, you're probably limited to about 30 meters of Cat 6 or better. Okay, it won't work on Cat 5. It needs to be Cat 6A or better. In terms of multimode, OM3, OM4, the frequencies are a little bit different there. You can get between 300 meters and 1500 meters. And what's being used more and more now is single mode fiber, which goes up to 20 kilometers. You can also use Ethernet RJ45. So if your 10 gig switch has RJ45 connectors, you can still use those. But you're going to be limited in length to about 100 meters. But you need really to make sure that your cables are Cat 6A standard and really double check that they are for this to work. So different fiber optic cables. I'll go very quickly over this. So that's what the cables look like for those that aren't familiar, especially with the twin-X stuff. The twin-X is actually quite cost-effective and durable, and they're really useful for the shorter lengths. So they're actually quite sturdy. OM3 multimode or single mode fiber, can go a lot more further, of course. But you need to be a little bit careful on the connector side of things. On the connector side. these different types of connectors, I just want to underline the fact that we actually use LC, SFP Plus uses LC type connectors. That's what it looks like. Multimode fiber transceivers and single mode fiber transceivers, although they look the same, they use the same LC connector, they are not compatible with each other. They don't use the same wavelengths, and it's a different way of transmission. And that actually, that's actually very important to remember. So in terms of SFP transceivers, the Terra TX, the RX ship with generic LC multimode OM3 transceivers, so 850 nanometer wavelengths. And you need to use the same mode of wavelengths on both ends of the cable. So if you want to use the SFP Plus transceivers that ship with Terra, then you're going to need to get LC multimode OM3 transceivers for your switch, and they need to be coded to the switch that you're using, and that's why we don't supply them for the switch that you want to use. So, for example, an SFP Plus transceiver that's coded for Netgear isn't going to be you can't use that. It's not compatible with Cisco switches. And of course, I've already talked about the different types of transceivers available on the market. You know, single mode fiber and RJ45, and that's what they look like on the right-hand side. So again, the only thing I want to underline again is that you know, the Terra ships with you know, a generic OM3 SFP Plus transceiver. A little bit about multimode and single mode fiber again. They're not compatible, as you can see. The wavelength is different, and the cables are different as well. So OM1, so the cable on the left is OM1 multimode. The cable in the center is OM2, 3, 4, and 5 multimode, and the cable on the right is OS2 single mode. So as you can see, they're very different. They're very different cables, and the way that the data gets sent, or the light gets sent down there, is very different as well. So you need to make sure that the transceivers that you're using and the fiber cables that you're using are actually compatible. We're open to questions now. So, Tom, if you're still with me, and I hope so, what have we got? I mean, how?
I'm with you, man. I'm with you.
Okay.
I'm with you. First of all, thank you, Nick. Was a pleasure to listen to you. I hope all the others out there enjoyed it as well. We still have over 200 people following us. I just wrote down, I think I was able to answer most of the questions that came in during the webinar. A couple of questions that came in asking about picture-in-picture capabilities of Terra, which is only possible in the multi-view. So this idea gets, big to use Terra in multi-view mode to get some picture-in-picture processing.
Yeah. So obviously the issue with that is the bandwidth, right?
Absolutely.
So in theory, yes, you can do it, but the receiver is still limited to that 10 gigabyte bandwidth. So, for example, if you're displaying 4K, if your monitor that the receiver is 4K and the receiver is the multi-view mode, and you have something that's full screen, so it's actually being displayed at 4K, you have very little bandwidth left to be able to display a window, in picture-in-picture mode, right? So right now, so it's sort of not really designed for that. Terra isn't really designed for that, for picture-in-picture. You can sort of cheat it a little bit, but there are a lot of caveats. You need to be careful on the bandwidth. But stay tuned. There's a lot more that's coming down the line in terms of product development on the SDVoE technology that we're working on. Stay tuned. Terra is just the first stepping stone for Christie into the SDVoE world. It really is a switching mechanism. Okay, it's something that you're going to use to switch things around the network. That's what it's designed for. The kind of picture-in-picture and video processing stuff. It looks very promising, but stay tuned. That's not Terra yet.
Keep on talking about the multi-viewer. A couple of questions came in asking, okay, does this and that fit into the multi-viewer? Or if I have this inside the multi-viewer and I have this bandwidth left, does it mean that I can add another 4K source or whatever? This is not easy to answer. Even if you calculate how many bandwidth you already have in your multi-viewer so that you have still bandwidth left, does not mean that the transceiver of the source has enough bandwidth to fulfill that. So these questions are not easy to answer because you always have to check both sides. Even if the RX has bandwidth left within the 10G, it might be that the transmitter of the source is already close to the edge because it is transmitting a 4K source in stream 0.
You're absolutely right. So you're absolutely right, Tom. You need to look at both ends. Like I explained, and maybe we can go back to the slide. If there are a lot of questions, maybe we can go back to the slide that concerns multi-viewer. Go back here. This is on the transmitter side. What you really need to remember is that the higher the resolution the input is on the TX, the less bandwidth you have for stream 1. Okay, so the transmitter is always going to favor. It's always going to prioritize the stream 0 in terms of bandwidth. It's always going to send it out as close, either native resolution or as close to native resolution and as it can get it. The higher the resolution input, the input is, the more bandwidth that stream 0 is going to use. So yes, you do need to be careful. So it doesn't mean just because the receiver still has bandwidth to go to be able to display more stream 1s, as it were, it doesn't mean to say you can go and grab a stream 1. The stream 1 actually on the TX side needs to be available. So you do need to be a little bit careful about that.
Another point, a lot of questions came in talking about other switch manufacturers like Netgear. I think you made yourself very, very clear. As long as the switches fulfill the requirements for SDVoE, like IGMP snooping, IGMP querying, you've been through all that stuff. As long as the switch is fulfilling these requirements, there's a high chance that you can configure them to work with SDVoE, right?
Yeah, so it needs to be 10 gigabyte non-blocking. That's the most important thing, okay? All the ports must be able to take 10 gigabytes full bandwidth simultaneously. So beware, that's the most important thing to remember. It does need to be a level 2 programmable switch, for the multicast and stuff, but you've got to be careful on the bandwidth side so that the switching fabric behind it is big enough. You need to be able to load up that switch with 10 gigabytes on every port and still be able to use it. You'll have some switches that are out there that have 10 gigabyte ports on it, but the switch fabric behind it won't support, all the ports at 10 gigabytes, because on average, you don't usually use in most applications that are not video over Ethernet. or SDVoE, most applications you wouldn't use, 10 gigabytes all the time. But for SDVoE, it does really need to be non-blocking. That's the most important thing.
All right. In the case study, can you, wait a second, I have to, can you connect the Terra controller with the Crestron touchscreen without the Crestron processor? Does that make sense? This is
that's a question for Crestron, really.
okay.
I don't know. I can't actually answer that question.
Okay, no problem.
Sorry.
Here's a good one. How Christie Terra differs from other brand AV over IP manufacturers or systems. Let's make another webinar about it.
Yeah. Okay, briefly, yeah, there are a few differences. One, the first difference is that within the same sort of TX and RX, you actually get pretty much everything. So you get RS-232 infrared and USB, DisplayPort and HDMI inputs, and Ethernet. You get all of that sort of packaged in the same sort of TX and RX. So that's the first thing. So you get everything pretty much, okay, with Terra. And the second thing is the controller. Now, the controller is really important. Why? Because the controller is really the thing that gives you the flexibility to be able to easily manage the whole system in terms of setup and updating the TX and the RX, creating layouts that you can recall, modifying those layouts, even working on the fly, live. Changing receiver modes and so on the fly. All that's done using controller, and the controller memorizes all those configurations and layouts and so on. And you can have a backup controller as well for redundancy. So those are the sort of the big differences between Terra and some of the other stuff that's out there, even in the SDVoE world. So it's a very cost-effective and sort of total solution, as it were.
Okay. There's a follow-up questions to that. Other brands, AV over IP, need 1 gigabyte network switch, but Terra needs 10 gigabyte. Why?
Okay. We need 10 because we do not compress. We want very low latency. Okay. And we want extremely high quality video and color at the other end. So when you're using a system that runs over a gigabyte network, what you have to do is to compress the video, even if it's HD, uncompressed HD. Okay, the video signal, uncompressed HD, 3.5 gigabytes. So even HD, you have to compress that down so it goes into a 1 gigabyte network cable. Okay, that's a lot of compression, and the whole of the video signal needs to get compressed. Okay, so that means that you need a codec for that. So JPEG 2000 or H.264 or whatever you want to use, and the compression actually takes all the color out. So it's taking out pixels of color to be able to compress that. Then and that takes time. So it encodes all that color data and pixels and so on. It takes out a lot of the color from the pixels as well. That takes time, and then it gets sent over the network, and then it sort of needs to get decoded. But while it's being decoded, it's actually lacking a lot of color data that they're actually at the source. So it extrapolates color at the end while it's decoding, and the decoding also takes time. So you get something that has, quite a lot of latency. I mean, we have products, for example, Phoenix does that. We use H.264 for our Phoenix control room processing product, which is which is great for some, for some solutions. If you don't need, 4K 60, 444 with low latency and Dolby sound, all that kind of stuff, then and you can get away with something that's with a lot of latency, and you don't really care about the color at the other end and so on, then a gigabyte solution would work, like Phoenix, for example. But what we're trying to do with Terra and SDVoE is give you not only high quality video and audio, but also give you KVM and RS-232 and infrared and all of that at the same time. Okay, so that network switch, that 10 gig network switch, actually replaces multiple networks, multiple switches of different kinds. Okay, audio, video, KVM, RS-232, and so on. Okay, so it's sort of horses for courses. There's only so much you can fit into a 1 gigabyte, network, and there's a lot of compression. So yeah, so the goal is really, and the reason why this is taking, SDVoE is actually taking off as a standard is because the cost of a 10 gigabyte network switch and the cabling and so on has fallen considerably. We're talking about, $100 right now, probably about $100 a port in terms of costs on the switch. It's getting, the fiber cables are sometimes cheaper than standard copper now. Okay, so the cost is actually coming down, and what we've seen is that the request for bandwidth, whatever the application, continues to go up. It skyrockets. So SDVoE is actually future-proofing your video over IP, solution. So I hope that sort of replies to the question, Tom. I could go on for hours like this. So.
Yeah, that's it. Another good one. Where is the upscaling occurring? Imagine you have a 1080 60p source and you are transmitting to a 4K screen. Where is the upscaling being done?
The upscaling is being done on the receiver. Absolutely. Okay, on the receiver end. The transmitter, so you're transmitting, in Tom's example, 1920 by 1080, and stream 0 is going to be 1920 by 1080 at 60 frames a second. It's going to take up 3.5 gigs of bandwidth, etc. And it's the receiver that's going to receive that and scale that up to the output, to whatever resolution you need. So yeah, it's on the receiver end.
All right, Nick, are you familiar with Atlona?
Vaguely.
Okay, so I guess we can't answer these questions because it's a comparison with a different system. If we don't know the other system, it doesn't make sense. How to manage ordinate Dante into the system?
Aha. That's a good question. Netgear is working on this, to be honest. So, big differences between sort of network requirements with Dante and SDVoE. I mean, obviously it's still multicast and so on, but Dante requires a lot of QoS stuff to be enabled on the network in order to be able to, for the sync and timing to be right. And the QoS stuff is actually not required, and in some cases sort of detrimental to the SDVoE part. So I'm going to say two things. You can use both on the same physical network. I create different VLANs, one for SDVoE and one for Dante right now. Dante doesn't take up much bandwidth. It's like a gigabyte max, so you don't need a 10 gig network switch for Dante. But wouldn't it be? But well, it depends. I know that Netgear, I think, are working on something to be able to differentiate between the two types of signals, so that certain QoS stuff gets activated on ports that are recognized as being Dante and not when it's recognized as being SDVoE. I'm not too sure of that, and so stay tuned for more info on that as they develop that kind of solution. But right now, you probably need 2 separate VLANs because the ports will need to be configured differently.
Yeah.
In a perfect world, it'd be great to use the Ethernet connections on the TX and the RX, but yeah, I'm not sure how that will be handled right now.
All right. Can we route the HDMI audio from Terra network to be audio source in the Dante network? I guess same thing like before. I think they are working on it, right?
Yeah. It would mean right now, no. Dante and SDVoE are separate, and that requires some work between Ordinate and I guess the alliance to converge SDVoE and Dante together. So you get a sort of a Dante output from a TX, for example. Whether or not that's feasible right now, I don't honestly know. I don't have an answer to that question. Right now, they're very different in terms of requirements, from a network perspective. So it'll be tricky.
And some more questions are coming in regarding the scaling. Which scaling is done by the RX? Which scaling is done by the TX?
Okay, so I'll start with the TX. The only thing that the TX scales is stream 1. Okay, so that second thumbnail sort of source that's available. That's the only scaling that TX does. Okay, and that's user defined. So you can make it as big or as small as you want, and you want to try. And you need to try and fit it into that 10 gigabyte bandwidth output that the TX has, going onto the network. So stream 1 is the only scaling that the TX does. The RX scales the output, so the output, the HDMI outputs on the RX can be, HD, can be 4K, but your source can be anything as well. So, like Tom's example earlier on, if the RX is connected to a 4K monitor, for example, and you want to display an HD source on it, then the HD source is going to be transmitted native resolution, native frame rate, 0 latency over the network to the receiver, and it's the receiver that's going to scale that stream 0. Okay, it's going to scale stream 0 to the output. Okay, the receiver doesn't scale stream 1, by the way. It does not scale stream 1.
Or Dante. Switch. Well, we were talking a lot about switches today. Network switches, fast switch mode, switch sources. So a lot of switching.
Yep.
If we have to switch sources in the fast switch mode, it's going like this. It's not seamless, but it's going very, very fast. There have been a couple of questions about the time needed to switch between different modes. For example, to switch between a multi-viewer mode back to a Videowall mode, back to a fast switch mode. I don't have a table for that, but probably you can tell something about it.
Yeah, I'd estimate about I don't know. It'll take, I'm going to say, several frames to be able to do that, because what happens is in that mode, because especially in the Genlock mode, there's no buffering at all. Okay, so even Genlock scaling mode, there's sort of very little buffering. There's only scaling. So what happens is that the receiver, when it's displaying a source on a display, it's subscribing to that source over the network. So the transmitter publishes the source and the receiver subscribes to the source. Okay, this is how multicast works. And when you want to change the source, the receiver needs to drop the source, so unsubscribe from it, and then subscribe to a new one. Okay, so while it does that, this screen's going to go black. Okay, so it unsubscribes from one source, subscribes to the new one, and then displays it. So it does take a little bit of time. I don't know, it's under a second maybe. It's not that slow, but it will go through a black screen though in that mode as it sort of handshakes again, because there's also the EDID stuff, especially in Genlock mode, HTTP and EDID handshake that needs to be done as well every time you switch.
All right, another question, as far as I see, probably the last one for today. Is it possible for the receiver to receive a 4K signal from the transmitter and display its fourth part, so only a quadrant of the 4K signal, provided that the receiver and transmitter are connected directly? I'm not sure if I get the question right, but is Terra able to get out a quadrant of a 4K signal?
Now, if it's point to point, what goes in comes out at the other end. So if you've got 4K going in, you're going to have the whole 4K signal coming out at the other end, regardless. You can't map, a certain part of the video image. Terra can't do that. Unless you're in Videowall mode, then the answer is no on that. You can't sort of pick a quadrant, a 1920 by 1080 part of a UHD signal, for example, and display that, especially when the TX and the RX are linked directly.
That's it. The only thing where exactly this is happening, this is not this setup, but exactly this is happening when you use the Videowall mode. Stretching a 4K source over multiple display, then exactly this is happening.
That's right. That's right.
All right.
You could probably actually. There's one way you could probably trick the system into doing that. Is the receiver where you want the quadrant to be displayed? You would create a Videowall destination, a 2x2 array, okay? But you would only assign a single receiver to the quadrant that you want to see. And therefore, when you drag the source into the array, that particular, the receiver would only see the top left-hand quadrant or the top right-hand quadrant, depending on where you assign the receiver to, in that 2x2 array. So you could probably cheat it that way in Videowall mode.
I like it. We are trying to train people to use the system how it is supposed to be used, and we start on training the people how to trick the system. I really like that.
Well, I mean, that's the flexibility of it. It's cool.
That's good. So far, so good. I just released 2 support email addresses in the chat function for the US and for the European area. So everybody who has more complex questions is free to shoot out an email to one of these 2 email addresses. That's from my side. Can we use the Videowall mode for a 2x2 video wall and in the same time use multi-view mode to receive multiple source on this video wall?
Well, yeah, the answer is yes, of course. So in a 2x2 video wall, you'd have 4 receivers. Now, those 4 receivers can change mode at any time. So it can change from video wall mode, where you have a single source displayed across your 2x2 video wall, and you can take one of those receivers and switch it into multi-view mode, and then you would see your thumbnails on that receiver. So the answer is yes. You can actually switch all 4 of them into multi-view mode if you wanted to.
That's it, but you cannot mix. Or can you
cannot mix.
or can you cannot have a multi-viewer across the complete video wall?
You could have all 4 receivers in multi-view mode.
In 4 different ones.
Yeah, so
But
each quadrant would be a multi-viewer.
That's it, but it's not
Yeah,
one.
so your whole video wall would be one massive multi-viewer. You could do that, absolutely.
With one multi-viewer.
No, you'd have 4 multi-viewers. Okay, but so each quadrant of the array would be a separate multi-viewer because you have a multi-viewer for each receiver, right?
That's it. It would be a separate multi-viewer.
Yeah, so you have 4 separate multi-viewers, one in each quadrant. So yes, it is possible. What you wouldn't be able to do is overlap a source between, between receivers. Okay.
I think that's it. That's it so far. I think questions. Okay. Maybe we can talk about the sync between multiple outputs in a system. What especially do you want to know? So as I said, all questions being done. I'm still waiting for a couple of seconds. Some more questions.
Oh, I guess you're talking about sync in Videowall mode.
That's all I have.
Maybe. I'm not too sure what the question is there.
If I wanted to do a multiple projection setup, if you wanted to do a multiple projection setup with synchronized systems, is Terra a system you can use?
So I mean, you'd use Videowall mode, and set them up side by side. Having said that, the latency is so low, you probably could get away with it in like Genlock or fast switch mode as well. But certainly in Videowall mode, it would be possible. Although, if you're lining up projectors and they need to be butted up, there's no overlap, there's no blending, and so on. Because because Terra is a matrix switching system, as it were. That's sort of its basic function. There's no blending, there's no overlapping.
Here's another one. Thanks. It would be great to have another demo on the Videowall mode. The Videowall mode indeed is a pretty cool stuff. Remember, Nick, the National Opera and Ballet in Amsterdam used the Videowall mode to streamline their system because they had a 4K output, so one transmitter being fed with a 4K output and 4 receivers in Videowall mode that splitted the 4K signal into 4 full HD quadrants, feeding LED controllers for 4 different LED walls being located not together as one wall, but in different locations. So it was a very, very
interesting.
Lean way using one 4K source, Videowall mode, splitting it up into full HD, and you have 4 full HD sources that can be placed anywhere you want to see them. Can this output be decoded over a VLC player without using a decoder?
No. No. The signal, the SDVoE stuff. I mean, once again, we don't encode and decode, so we have transmitters and receivers rather than encoders and decoders. No, right now you can't. SDVoE doesn't cater for VLC or H.264 or things like that. So you couldn't. There's no streaming capability. That doesn't mean to say that there never will be one, but it's right now that's not the case.
All right. Projection. We talked about this. I'm running out of questions. I'm running out of questions. Still a couple of people left in the webinar.
Wow, it's still hundreds of them.
That's it. That's it. That's it. So.
Okay. Is that a wrap, Tom?
Sorry?
Is that a wrap?
Is that a wrap? What do you mean?
Is it over?
No, it's okay. Last answer covered it. Answer is no. Okay.
There we go.
Seems like problem solved.
Okay.
A lot of people saying goodbye right now.
Great. Well, thank you again. Once again, thank you all for joining this webinar. I hope you found it interesting. Let us know if you'd like, if you guys would like us to go into a little bit more depth into VLANs and stacking and stuff like that. Yeah, that'd be great. We could organize something on that. In the meantime, from all of us at Christie, we all hope that in the current coronavirus crisis, that you and your loved ones are well and safe. And so stay safe, look after yourselves, look after your families. And we will see you soon. And I think the next webinar that we're going to be organizing is going to be on the Terra Manager software. So we're going to go into live the Terra Manager software. Don't have a date for that, but we're working on it, so stay tuned. It'll be on the network shortly.
Perfect. And right now, they're coming in questions. Yes, we will do a webinar on network technology, a more detailed, a more technical webinar on network planning together, I guess, with an expert from Netgear. So stay tuned. We will let you know when this will happen. Oh, right now they are coming in. They are coming in, asking for VLANs and stacking and VLAN, another VLAN, another stacking. Yeah. Okay, so the interest seems to be pretty high. We will do something. We will do something to cover this knowledge.
Great.
All right.
Okay.
Thank you, Nick. Thank you.
Wishing you all a great day. Again, stay safe. Look after yourselves, and we will look out for on social media, on our Facebook page, and so on. You'll see an invitation to the next webinar, which is going to be about the manager software. So we're going to go into the manager and play around with it a bit. Stay tuned. Have a great day.
Bye-bye. You stop the transition?
Yep. Okay, stop recording.
Yeah.
And where is it?
Different screen?
I don't see anything. Where's the video?
So did you stop the recording?
I stopped the recording. I stopped showing the screen.
Okay, then there should be some kind of pop-up window, I guess.
Yeah, I'm not seeing it. Hang on. I'm not seeing it at all.
This session is...
Are you seeing anything?
No. Oh, wait a second now. Edit your name, email, go to what? Huh? Okay. I don't see anything, Nick.
Nor do I.
But there must be something. There you are. No.
What? Okay, we need some help on this.
So you stop the recording.
Yes, I stopped the recording. Maybe I need to change the presenter back to you.
No. I am the organizer and everything.